So far, I've been delivering a lot of bad news, but there is some sunshine to spread around. There are better ways to plan for sample sizes that can help you do research that is robust and replicable. The approach I'd like to talk about first is called planning for precision, which is also known by the name of accuracy in parameter estimation, or APE. Planning for precision is very straightforward. First, you define your research question. Then you define the level of precision or accuracy that you desire for your experiment. And finally, you calculate a sample size required to obtain that level of accuracy. Planning for precision helps you plan an experiment that will obtain a specific noise level. It's like choosing the right microscope for the type of anatomy you want to do, or the right amplifier for electrophysiology. Accurate results provide a foundation for further study. Let's stick to our example. To what extent is knocking out a specific gene neuroprotective from induced stroke? The analysis strategy is the same. We'll want to compare neurological severity scores in control and knockout animals after the stroke. In this case, though, we will plan our sample size to obtain a desired margin of error, just like pollsters do when they're studying political attitudes. To do this, you have to consider the measurement scale. The neurological severity scale measures stroke-related impairments on a scale from 0 to 18. So as a scientist, you just have to think about how accurate you need your results to be, and you can constrain this by thinking about the resources required. Now, the effect in Zhu et al. Was 4-point improvement. So you might start off ambitious and think, I'd like to estimate this effect within 1 point. That would be very accurate, but it would take 44 animals per group. All right, what if I only ran 9 per group? Well, there you'd get a margin of error of 3.3 points, which is pretty close to the 4-point benefit, so that's probably not really as precise as we'd like to be. You might end up settling somewhere in the middle. You could get a margin of error of just 2 points with 21 animals per group. That's a lot more than people typically use for these types of studies, but your results would be a lot more precise, and therefore would provide better guidance for additional research. How do you do these calculations? Well, there are a number of tools available. Ken Kelly, who I've already mentioned, is a leader in this approach as well. He calls it accuracy in parameter estimation, or APE, and has a package for all R called MBES, which helps you plan for precision. His website has web applications that make it easy to use these functions without having to learn R. Another free tool is called Esky. It was written by a collaborator of mine, Jeff Cumming, and it's a website for planning for precision. It's really easy to do this, much easier than planning for power. Using Cohen's d, you dial in your desired margin of error. The red line tells you the sample size that will 99% of the time obtain your margin of error or smaller. Now, how do you decide on a target margin of error? There is no specific algorithm. It takes thought, expert judgment, and consideration of the resources available. But I can give you 2 rules of thumb. First, if you have a target effect size in mind, your margin of error should be no more than half as big. Otherwise, you would have a strong risk of non-detection. But what if you don't have a clear effect size prediction? In that case, a good rule of thumb is to shoot for a margin of error that is theoretically homogeneous. That is, try for a level of precision so that within the confidence interval, the differences between scores aren't especially meaningful or important. The planning for precision approach is my preferred way for planning studies. It's pretty intuitive, even for those who don't love statistics. It works well even if you don't have very clear expectations about effect sizes. It also helps you make so-called negative data more interpretable. You can prove that the effect is smaller than anyone would want to further study. There are versions of this approach for both frequentists and for Bayesians. It's also easy to evaluate after the study. If you find an effect, but it's similar in size to the margin of error, your sample size is inadequate. Why isn't everyone using planning for precision? It's a good question. Why isn't everyone using planning for precision? One con is that there aren't as many resources or tools available, but that is changing quickly. You can see the resources section at the end of this workshop for some tips.